Hello pre-calculus students, and welcome to a video on how to find the domain, range, and determine whether a graph is a function or not. So that's the vertical line test. So we're going to look at graphs. We're going to look at starting out with these four graphs, and we're just going to determine first whether or not it's a function. Second of all, if it is, whether it is or isn't, we're going to find the domain and range of the graph, or of the relation that the graph represents. Remember that if it's not a function, it can still be a relation, which is any correspondence between a set of ordered pairs. And a function is that special correspondence that will be covered in another video, but it's that special correspondence where each input corresponds with exactly one output. Okay, so first a little bit review of the terminology, domain, range, and the vertical line test. So the domain is all the inputs in a relation. It's the x values in ordered pairs. The range is the outputs, or the y values in ordered pairs. And the vertical line test is a test to decide whether or not a graph is a function or not. And the idea is that if any vertical line can cross or intersect more than one point, then it's not a function, because that means one input corresponds with two outputs. And so what we're going to just do is these three examples determine whether the graph is a function and state its domain and range. And let's look at this first one. Okay, so it's not a function. So why is it not a function? Because of all of the vertical lines that we can imagine, it only takes one to make it not a function. And this is that vertical line. So there exists a vertical line that crosses two of the points on the graph, and therefore the graph is not a function. So our answer here is no. As far as the domain is all of the x values. And so this point right here has an x value of -3. This point right here has an x value of -2. These points both have an x value of 1, and this point has an x value of 4. So all of those points together make up the domain. So our domain, which is a set, so we're going to use the set brackets, consists of the numbers, just the inputs, just the x values, -3, -2, 1, and 4. Okay, that's the domain. Now for the range, we're going to look at the y value. So we're not going to look down at the x-axis, we're going to look over at the y-axis. So that's a bit thick, what I need to do here. Okay, so that point has a y value of 5. This point has a y value of -4. This point has a y value of -2. Here's one with a y value of 0. And here's one with a y value of 3. So we have to just include all of those points. So we'll just start at the bottom and work our way up. Okay, so the lowest one I have here is -4. So my range is the set of outputs, -4. Going up, I have a -2. Continuing up, I have 0. And then 3 and 5. And that's the range. Okay, there it is when you have a set of ordered pairs. Now what if you have a graph? So if you have a graph, these are going to be more like intervals as opposed to just single numbers, because here on number 1 we could list them all, but typically we can't do that. Most of the time we won't be able to. And so in this case we're going to look at the graph itself and notice that there is, I'm just going to kind of imagine all of these points getting dropped down, and right here, right below this point right here comes down, there's an open point there. All of these points are going to be included, and then forever, because this arrow means it goes not only upwards, but it also goes to the right indefinitely. So the domain of this one is everything from -4 to infinity. So we'll put that in interval notation from -4 to infinity. And because of the open circle here at -4, we're not going to count the endpoints. We're not going to be inclusive. And by the way, I guess I skipped whether or not this is a function. And this one, unlike example 1, there's no vertical line that can cross more than one point. So this one actually is a function. And for the range here, we're going to pretty much do the same thing, only this time we're going to look at how points go towards the y-axis. And so all of these points from here, I'm just going to kind of point out all these kind of land here. They all have the same y value, everything on this red line that I just made. And then all points are covered. Now some people get confused because there's a hole over here, right? So yeah, there's a hole, but then over here, what happens to that hole? It gets filled in. So we didn't really need to put anything there. It's just a continuation, goes up forever, and the range is everything greater than and including 1. Okay? I'm going to give you a minute to try example 3. Actually, maybe I won't. This is a rational function. So this one has, I recognize it because I've already taken the class, and I know Chapter 4 is all about rational functions, and this is one of them. Now, one thing that's distinct about rational functions is these asymptotes. Now, right here it is an undefined, like if we were to take all the points and put them on the number line, I guess I'll do this in blue, there would not be any point there, and there would not be any point there. Nothing from up here is going to have an x value. Let me make sure that's clear. Nothing from up here has an x value at -2 because it's getting closer and closer to that, but it's clearly an asymptote by the way that it's drawn. Okay, so -2 is not, and same thing down here. Even though these points down here are getting closer and closer to that -2, there's not going to be a point there based on the way that it's drawn. So those 2 points are excluded, but looking at the graph, everything else is actually there. So when we want to describe the domain, and by the way, I keep forgetting to do the function part. This is a function, so there's no vertical line that crosses more than 1 point. These vertical lines that are asymptotes don't cross any points, and anything to the left or right of them only crosses 1 point. So this is, in fact, a function. And the domain, we can see here that there's 3 different intervals. It goes from -infinity to -2. And not including -2. And unioned with the stuff between -2 and 2. And then unioned with everything greater than 2. So unioned with 2 to infinity. Okay, now the range looks like the range on the top part is also asymptotic going this way. So if you kind of see, it's approaching 0, but it's never going to quite hit 0. And by the way you know that it's never going to reach 0 is because if I were going to make a graph and it intersected with 0, I would show that part. I wouldn't make it just look like it's getting closer and closer and make you wonder, I wonder if it will ever pass 0. If it was going to pass 0, it was going to cross that. This is a very important point. That's an x-intercept. I would show that point on the graph. And the same thing with y-intercepts. And the same thing when you see these dotted lines for asymptotes. If it was going to cross the line, we would show that in the graph. So you can kind of imply, just assume that that's the case. Okay, so the range now doesn't include 0 because it's asymptotic in going in this direction. Let me just kind of get my... So going in this direction, it's approaching 0. And in here, it's clearly missing 0. So it's going to be above 0. So we're going to have an open, let me do this in green, have an open circle at 0, but then everything above it, now I wish I had a thicker marker, and it's going to go up forever just like the curve does. And then there's a closed point here, it looks like at -1, and it goes down forever. So that's a visual of what the range looks like. So when I write that in interval notation, I'm just going to write -infinity to negative, I covered up all my numbers, this is -1. So -infinity to -1, including -1, unioned with, and it looks like it starts up again at 0, so unioned with 0 to infinity. Okay? We're going to be spending a lot more time with these kinds of functions later this week. Rational functions. And we're also going to be spending time with these. And think about this for a minute. See if you can, by the way, before I have you work on this, this is an end point here. That's a point, just to be clear. Sometimes it doesn't show it, and sometimes it does. You just have to, if there's not a hole there, it's a point. Okay, so I'm going to give you a minute and see if you can figure out the domain range and whether this is a function. And see if you can also kind of speculate what kind of function this might be. Okay, there it is. So this is a function because it passes the vertical line test. The domain starts at negative, oh, I put -3 and it starts at -5. Let me fix that. So it goes from -5, and because of the arrow over here, it goes to infinity. And the range starts at 0. That's the lowest y value. And even though it's going up very slowly and over very quickly, this is not horizontal. This arrow right here is not horizontal. It's definitely going up, so it's going to go up forever. You'd have to get some pretty big numbers to get, big outputs, but eventually it will happen. Okay, and this is a square root function, in case you recognize the look of the graph. And we can actually be very specific about which one it is, because the square root function has the point, I'll just graph this real quick, has the point 0, 0, and then the square root of 1 is 1, and the square root of 4 is 2. So there's the same pattern that we see here. It moves over 1 and up 1, and then it moves over 4 and up 2. 1, 2, 3, 4, up 2. That's definitely a square root function. It hits those points right on, and it's moved over 5 units. So this is vertically translated to the left 5 units, and we're going to review those transformations also on Thursday, or at the end of this week, Thursday or Friday. Okay, I hope you found this video helpful.